Kubernetes deployments. We will be working with Eager on Kubernetes. So therefore, to install Kubernetes, we need to make some changes here. This is my machine. Needed to enable at least two CPU. Under systems, under processes, we need to ensure that we have two CPU, minimum two CPU for this machine. So I have three, that is good for me, because Kubernetes will not work with one CPU. Second thing is, you must disable the swap. To permanently disable swap, I need to change the file etc fstab, and the last line have swap entry. There is a swap partition, and we need to disable it so we can comment it out. And to enable disable swap in this session, we have a command called swap off. Swap off. This will, oh sorry, swap off -a. That will swap off all the swap. That will this will disable the swap. Now we are good to start the installation of Minikube, which is single node cluster for testing, deployment, and all the functionality of Kubernetes, except that it is a single node cluster. Minikube, it is a Docker container. It will run Minikube in the container. So you will see that once the image is downloaded. I'm downloading this image. This is around 72 MB image. You can see the Minikube file is downloaded. So we need to change the permissions. Chmod a+x means all users execute permissions on this Minikube file, and then we need to put it in the user bin Minikube, and that's how we install. There's a command on Linux called install as root user. A group is root, and the permissions will 7455. Install this file Minikube in this directory. It could have been a simple copy command also, but this is the ideal command, ideal way to install a file, a binary file into Linux system. Now what we need to do is we need to download the kubectl command. This kubectl command is used to manage the cluster. So this is again a binary, and we need to do the same thing. So chmod a+x kubectl, oh sorry, a+x typo, and then we need to do the same thing with this also. Install kubectl, same process. This is the file name is kubectl. Install it under user bin kubectl. So this will install this file kubectl into user bin kubectl file. This is also done. That is kubectl. So this is the checksum file to verify the integrity of this file, kubectl file. So this checksum kubectl sha256 checksum, the integrity, that is kubectl sha256 for this command kubectl, and grep checksum. If it is display OK, then it is done. So kubectl is OK. That means the integrity of the file kubectl is OK. You cannot run Minikube as root user. If you want to, however, run it as root user, you have to use --force. But I don't want to use that method --force option. So I want to execute and run this Minikube or Kubernetes cluster as unprivileged users. So therefore, I'm logging out from my machine. I'll log in as Oracle user, and rest of the commands in the lab assignment also you will see they are executed as Oracle user. So I'm logged in as Oracle user. If you don't see any desktop icon or anything, what you can do is there's an option here under activities and search. There's a binary called tweaks. It's GNOME tweaks. If you search for tweaks, you will see GNOME tweaks. This is already installed. If not, you can install it, and once it is installed, you will get a lot of options. So let me finish the installation. I'll show you. This is good for Oracle Linux 8. This is applicable for Oracle Linux 8 to get the minimize button, to get the maximize button, and to see the desktop icon and all that. This is good for, this is Linux utility. Nothing about Kubernetes on this particular thing. So let's go one by one. First is Windows. Attach, where's that dialog box, middle click, yeah, this one, maximize minimize. By default they are off. So you see here on the this window also, you see, look at this area carefully. So maximize button, minimize button, they were not available. Placement is okay, left and right. Workspace, so dynamic workspace, that's fine. Windows top bar. Now on the top bar, what all you can see is clock. Right now it was not shown earlier. Seconds and week numbers. Setup applications, sound, power, all good for us. Show extensions, nothing special here. Fonts, nothing special. Extension, yeah. Extension, if you look at application menu, desktop icons are not visible. So click on this OK and you will see applications menu. Desktop icons are not visible, so click on OK, you will see. Horizontal workspaces, launch new instance, all these things like launch new instance for physical machine. If this machine is working as horizontal. Windows list, you click, you will see what windows are open here. So this is a tweaks that help you in customizing your environment as Oracle user because you will be doing it for first time. So search for grown tweaks, check the desktop icon and all these things. And now it will allow you to open this terminal also. This option otherwise would not have been possible. So sudo user mode, add the additional group Docker for the currently logged in user and change create this new group Docker. To run the Minikube, this will launch Minikube Kubernetes cluster, and driver is Docker, add-on is Ingress, and this will download and install. This will download the images because it's image. It will run in Docker container. So let's pull it. Let's run it. Once it is run, you will have a single node Kubernetes cluster ready on your machine, and you will be able to practice all kubectl related command and eager deployment on Kubernetes and clusters and pods. So that is a part of our demonstration or discussion. So that's why this is a prerequisite to discuss eager operators for Kubernetes. Let's wait. It does not take much time. It is almost done. You can see Kubernetes installation container is created, configuration file is generated, booting the control plane is done. Wonderful. It's great. We can check the status with Minikube status. Everything is going very well, team. As you can see, as long as we execute the command successfully, oh god, this is typo. As long as you execute the command successfully, everything will work. And now you see the Minikube is created, host is running, Kubernetes is running, API server is running, and this is configured. To launch the dashboard, you can type dashboard. This will deploy the Kubernetes dashboard, and it will display the URL of the dashboard where you can access the URL, which is a browser based, which can be accessed from the same machine. So this machine should be a GUI machine in order to launch the dashboard. Just wait and you will see it will display the URL of the dashboard. So you can deploy, you can create all manifest file, you can create everything from the dashboard as well. I'm demonstrating the dashboard so that you understand the Kubernetes from the graphical interface. That will give you a better picture what all components we have in Kubernetes, what are deployments, what are pods, what are namespaces, nodes, service, everything you will be able to see. And this is your dashboard, and it will launch automatically. You don't have to click. Interestingly, it will launch the Firefox browser and it will launch. So we don't have to do anything. I'm just waiting, and you see browser will be launched and it will log in. Yes, Minikube is not supported as a privileged user. However, we can do a force, but I don't want. Docker is binary, it is installed. But this Minikube is deployed as a container, but it is not supported as a root user until you force it. And I don't want to get into more problems if anything is depending on as root user, because this should be launched as unprivileged user as per the documentation of this Minikube. Okay, yeah. So here you can see jobs and deployments and pods and everything. This is a complete dashboard where you can manage everything for testing purpose. This is only for testing and training purpose, team, to give you a feel of it. The full 3 node cluster, you can watch the lecture, and I demonstrated that also, how to create a 3 virtual machine 3 node cluster, a Kubernetes cluster. You have to do even port forwarding will not work, it will fail. So this will be accessible only inside the machine, and I cannot use this terminal now. I have to open another terminal window in order to continue my practice. Very important point, and that's a clarification, very crucial. So I'm creating a namespace, kubectl create namespace observability, and observability is namespace is created. I can use kubectl get namespaces, and you can describe also kubectl describe namespace and namespace name. Observability is what we created. So give the name, it will describe that namespace, it will give the details of the namespace. So this is the namespace which we created. Wget and the URL of the file. So because this is available on GitHub, so I can simply pull this file so that we can investigate the file and then we apply the file. Done. So let's check this file, the jaegeroperator.yml. vi jaegeroperator.yml. This is the observability deployment file. This is the manifest file for that. So annotations, create timestamp, labels, name, specifications. So all these details are there. So we are going to simply deploy this manifest file directly without going into much detail right now. So for that we have command kubectl apply, or you can use create also. Create. Generally, the difference between create and apply is that when you are creating resources for the first time, you use create. When you make some changes in the manifest file and then you want to update the manifest in the cluster, you use apply. So create hyphen f and the file name. So this will apply the details, whatever resources were mentioned in the manifest file, it will create everything. So this is how you deploy a manifest file into the cluster. So this is the content of the file. This will apply. Again, the command is same. kubectl apply hyphen f. Kubectl namespace observability. So I'm going to deploy these into this namespace. So I can check this. Kubectl get what is kind. Kind is eager. So get Jaeger get eager get deployment. No, it is eager. So I don't know whether I'll get it or not. And hyphen m namespace is observability. Let's check that. Yeah, right now it is working. So it will take some time. Once it is ready, we'll be able to see the output here. Or Cubase system namespace. If you want to see all the namespaces, I'll show you. The command for that is simple kubectl get namespaces. Something like a system namespace or dashboard or your application monitoring or your own application specific namespaces. So just like okay, I'll give a simple example. In OCI we have something called compartments. If you have used OCI, what we have in OCI is compartments. So this is similar to that. It's logical grouping of resources. So in order to deploy independent application on Kubernetes, you create namespaces. What all namespaces we have, there's a simple command kubectl get namespaces. RAM needs to be increased. My RAM is 4 GB. It's better if I give 6 GB RAM to this machine because it's a heavy load. Sir, grouping of pod is replica set, and then we have controllers. So it's not only pods, any resource, like it can be a service also. So service is not a pod. You understand? Yes. Yeah, please, please. That is true. The correct answer. So got it? Thank you. So it will take time because of speed. So I know it is already written in your lab assignment. I have mentioned that you have to wait for 5 minutes. Give it some time. Session 10, eager deployment options. Agenda is Kubernetes, Frontend UI, CLI Flags, security of eager. Operators for Kubernetes. The eager operator is an implementation of Kubernetes operator. Operators are what? Operators are a method of packaging, deploying, and managing a Kubernetes application. So what we have is we have packaged, we created a package for this eager application to be deployed, to be managed in Kubernetes. So a Kubernetes application is what? It is an application that is both deployed on Kubernetes and managed using Kubernetes API and kubectl. Interestingly, you create a new kind. Let me put it that way. Because it is not a default thing, because in default what we have is Kubernetes kind is a very important term. There are four major elements in the manifest file what you can create a deployment, you can create a service, you can create. So these are kind can be service, kind can be pod, kind can be a deployment, kind can be replica set, kind can be. So kind, when you are creating a new kind, we may say that yes, we are creating a new operator. So Kubernetes application that is both deployed on Kubernetes and managed using Kubernetes API and kubectl. To be able to make the most of Kubernetes, you need a set of cohesive APIs in order to service and manage your apps that run on Kubernetes. Think of operator as a runtime that manage this type, as I said, this type of app on Kubernetes. So we are creating a new type for Kubernetes, and if you notice, we created after operators were deployed, we create instance of that using this manifest file where the type given was, the kind given was eager. So how do we install this operator? Eager operator can be installed to watch for new eager custom resources, that is the CRs, either in the whole cluster or in specific namespaces. When configured for cluster wide, the operator can watch for events which are related to eager resources in all namespaces, can watch the namespaces themselves looking for sidecar eager tracing.io inject annotation, can watch all the deployments to inject or remove sidecars based on the sidecar eager tracing.io inject annotation, can create cluster role bindings when necessary. So this is how do we install the operator. We first, when not using the cluster wide resources, you set a watch namespace to comma separated list of namespaces that eager operator should watch for event related to eager resources. So for example, this is a role binding. Kind is role binding, API version is this, and metadata is eager operator in my project. And then namespace is my project. Then subject kind is service account. We are creating a service account. Name is eager operator. Namespace is observability. Role reference, we are creating a role here, eager operator, and API group where it will be placed. It is possible to have eager operator running in a given namespace and manage eager resources in any other, like my project in this case. For that, we need to create a role binding as we have created here, a role binding. Refer to this example given. For each namespace, the operator should watch for the resources. This is how we installed. By default, operator will watch in the same namespace in which it has been installed. So create namespace observability. That's what we have done in the lab assignment. Take it as number one. And kubectl create the manifest file eageroperator.yml in namespace observability. This is number two. So number one is this create the namespace used by default in the deployment files. Second, if you want to install eager operator in a different namespace, you must edit the deployment file to change the observability to the desired namespace value. Then this second number command, this command, install the custom resource definition for API version eager tracing. This will be creating this. Then after that, at this point, there should be a eager operator deployment available. So you can use kubectl get a deployment deployment name, and namespace. Even if you don't specify this, that's fine. You can type deployments. You can use the plural form. It will show you all the deployments. Operator is now ready to create eager instances. So we can, there are several aspects: front-end configuration and UI configuration, for where UI can be configured. The dependencies section can be enabled or configured. App analytics tracking can be enabled or configured via Google Analytics or custom plugin. Additional menu options can be added to the global navigation, and search input limits can be configured. We are talking about the front end of the eager. Search limits can be configured. These options can be configured by a JSON configuration file. The query UI config command line parameter of the query service must then be set to the path of the JSON file when the query service is started. And this is the example of configuration file where we are creating to understand that. In this example, there's a JSON configuration configured, the configured menu that have the drop down label at about eager. Let's see where that entry is. So this is the menu entry, if you look at closely. So this is the menu entry which will be created. So this will add a label. Label will be about eager, and then item of this about eager will be label GitHub and the URL of eager, then label docs, URL of the docs. So you can add more items like this using this JSON file. Similarly, search and other options, these are other settings, default settings. So you can create this in the JSON file. This is again, this is manifest file. So you can use this manifest file to add your own menus and options in your interface, user interface. This is a highly customizable interface. The menu section, which was given in the manifest example, allow additional links to be added to the global navigation bar, like label some text here and the URL of the text. Links can either be members of the menu entry directly, or they can be grouped into drop down group option, menu option. The additional links are always right aligned. The format of the link at the top right menu is this. Now format for a group of link is label drop down button and the items. The items array should contain one or more link configurations. Embedded mode. Eager UI provides an embedded layout mode which is intended to support integrating Eager UI into other applications. Currently, the approach taken is to remove various UI elements from the page to make the UI better suited for space constraint layouts. The embedded mode is included and configured via URL query parameters. To enter the embedded mode, you need to set this value UI embed v0, that is query parameter, and the value must be added to the URL. This localhost colon 16686 trace ABC, and here you are specifying the embedded UI embedded equal to v0. This URL will show the trace ID with ID ABC123 in embedded mode. Each page supported has a button added that will open the non-embedded page in the new tab. The following page support embedded mode: search page, trace page, and this is example. To integrate search page trace to our application, we have to indicate to the Eager UI that we want to use the embedded mode with UI embed equal to v equal to 0. So when you run this command localhost 16686 search, and inside that we are giving the URL that yes, that the UI embed equal to v0. That's how we are passing this parameter. So in addition to the query, you can pass this parameter, and when you pass, it will run in the on the search page, will also run in embed mode. Same thing can be done on trace page, like here. To integrate to the trace page of our application, we have to indicate the Jaeger UI that we want to use the embedded mode with the same setting. So here, this is the trace ID, and then question mark, and then this UI embed mode equal to V0. If we have navigated to this view from the search trace page, we'll have a button to go back to the result page. Now there are some important CLI flags when you are running it from the CLI. CLI flags for some binaries change depending on the span storage type environment variable. Some binaries support commands, mostly informational, such as env, docs, version, and status. All parameters can also provided via environment variable by changing all letters to uppercase and replacing all punctuation mark with underscore. For example, the value of the flag Cassandra connection per host can be provided by uppercase Cassandra underscore connection underscore per underscore host environment variable. The CLI flags for the following binaries categorized into Jaeger all-in-one, Jaeger agent, Jaeger collector, and Jaeger ingester, and Jaeger query. Securing the Jaeger installation. How can we secure the Jaeger installation? We have to look at different aspects like client to agent. Deployments that involve Jaeger agent are meant for trusting environments where the agent is run as a sidecar. When I'm using the term sidecar, please understand team, I'm talking about a pod in which multiple containers are running and one container is running for this purpose agent in the same pod. So when it is running as a sidecar within the container's network namespace or as a host agent. Therefore, there is currently no support for traffic encryption between the client and the agents. So therefore, if I ask you simply sending trace data or UDP, no TLS authentication, so not supported. Retrieving sampling configuration via HTTP, no TLS, no authentication, not supported. Client to collector. Clients can be configured to communicate directly with the collector via HTTP. So at this point, at this time, Jaeger backend does not provide mean for configuring TLS for its HTTP servers. The connections can be secured by using a reverse proxy placed in front of the collectors. So HTTP, no TLS authentication, not supported. Sample Jaeger, some Jaeger clients support passing auth token or basic auth. Agent to collector, yes. gRPC TLS with client certificates on the authentication is supported. Collector query to storage, yes. Collector to storage or query to storage is Cassandra. TLS with the MTLS is supported. Elasticsearch TLS with MTLS supported. Bearer token propagation is allowed. Kafka TLS with various authentication mechanisms is supported. Browser to UI, HTTP, no TLS, no authentication. Check more details at this protecting Jaeger UI with OAuth sidecar proxy. The link is given for your reference. Consumer to query service. HTTP TLS with client certification authentication is supported. gRPC TLS with client certification authentication is supported. That's all for this session. Thank you very much, team.